Hello, my name is Mia, and I will be going over enzyme kinetics mode of action. The learning objectives for this video are to go over what enzymes are, what substrates are, how they come together to form a product, and two different models on enzyme-substrate binding. First, we need to understand what an enzyme and a substrate is. In chemical reactions, enzymes are the catalysts that speed up the rate of a reaction. They do this by lowering the activation energy needed to change a reactant into a product. The enzyme is not used up in the reaction and can be used over and over again so more reactions can happen faster. Because of this, the concentration of enzymes required is low. In general, enzymes have the suffix "ase" at the end of their name for easy identification. Substrates are the reactants that become the products. Enzymes and substrates are specific to one another. Enzymes have an active site. This is where the substrate binds to the enzyme and are then converted into products. The products pop off the enzyme, and since the enzyme is reusable, it is now ready for the next substrate to be converted. Enzymes make a non-covalent bond, which means they don't share electrons with the substrate. This bond releases energy, which the enzymes use to orient the substrate so it is facing the right way to fit into the active site, and to facilitate bond making and bond breaking with the substrate during the reaction. The enzyme active site and the substrate must be compatible in shape, electrical charge, and chemical properties. The lock and key model was the first model about enzyme active sites and substrates proposed. Some enzymes have active sites that are less flexible and more specific to the type of substrate that binds to it. Only a substrate of the correct size and shape will fit into the active site of the enzyme. Any other substrates will not fit and the reaction will not be catalyzed. This is much like a lock and key, how you need a specific key for a certain lock. One enzyme that is an example of this is glucose oxidase and a specific chemical orientation of glucose. No other orientations of glucose will fit this enzyme. The next model is the induced fit model. This is where the enzyme's active site is more flexible and molds itself to the shape of the substrate. The general shape of an enzyme's active site will align to and accommodate a family of substrates and their varying shapes. This means that a single type of enzyme can catalyze more than one type of substrate. A commonly used analogy is how a glove contorts itself around different shapes and sizes of hands. For example, me and my sister have the same length of hand, but I have short palms and longer fingers, where my sister is the opposite. Yet we wear the same size of gloves, and the gloves fit around our hands perfectly. In summary, enzymes and substrates come together to make a product. We saw that enzymes increase the rate of reactions by lowering activation energy and can be used repeatedly. They are only needed in low concentrations because they are reusable. Substrates bind to the active site and are converted into products. We looked at two modes of action. First, we looked at the lock and key model. This is where the enzyme active site is rigid and only one type of substrate can unlock it. Next, we looked at the induced fit model. This is where the enzyme active site is more flexible and can fit an array of substrates within the same family.